Okay, so how is everyone today? Good, I hope. We're good. I don't want to talk about it. just start your thing. All right. Good. So today's the 14th. Good. All right. And last time we had begun talking about R2, which is to say the plane. So to bring us back to that, we had R1 like that, and then it's drawn just as a number line, okay, just a horizontal line, and the increasing direction is indicated by the arrowhead. If you feel it necessary to write it going both ways, then go ahead. But I would suggest that that might not be a good idea. And so if you select 2 points, named A and B, then as it's arranged, I could ask, what is the signed distance from B to A? Now you can't, because I didn't draw a scale, there's no marks on it. Like, you can't tell me exactly the value, but you should be able to tell me the formula. So what's the formula? What is it? A minus B. Now wait a minute, why is it not B minus A? Well, in the end, because it says from B to A. Okay, so then, conceptually, you imagine what that means is that you're starting at B and ending at A. And if you've taken a physics class, they're fond of saying it in this kind of way, that it's always going to be final minus initial. Right? Final minus initial. So from B initially to A finally. Fine. So you can't tell me the value of A minus B, but it's you can't tell me the value of the signed distance from B to A, but you know its formula is A minus B, and you should be able to tell me the sign of this. Is it going to be positive or negative? Negative. The reason why, in the end, is because, look, it says that you're initially at B and you're moving toward A. So if you move from B to A, are you moving with the world direction or against it? Against it. So that's got to be negative. All right. And then when you're out on the street talking about distances, you basically never mean signed distance. Unless you're like outside of like a physics conference or something, then maybe you mean signed distance. You usually mean unsigned. So the unsigned distance from B to A is what?
Absolute value of A minus B.
Very good. So you take the signed distance, in fact either one, A minus B or B minus A, doesn't matter, and what you do is you calculate the absolute value of that. Which is to say that we're not interested in whether or not you were going with the world line or against it. Rather, we just want to know how far it was that you traveled. Okay. Distance. Any question about this? Then that's R1, and then R2, is instead of having one axis, now we have 2 axes. Like that. We have a horizontal axis, a vertical axis, the increasing direction for the horizontal axis is to the right, just like that, and then the increasing direction for the vertical axis is up, and you can always see that with the arrows. And this one is always reckoned as the first axis, and that one the second. So first, second, yes?
In the first example, R1, if you drew the arrow to the left instead of to the right,
Mm-hmm.
would the signed distance be a positive number? Since the drew
Yes.
the arrow left? Okay.
Because when from B to A, so B to A, like this.
Right.
So to interpret your question, I think you're saying is that if I hadn't drawn that arrowhead, and if instead I had put it right there,
Right.
would that be?
Positive signed distance.
It'd be positive, because you'd be going with
Right.
the world.
Yeah.
But you also need to understand that that is like when someone draws a number line, there's like something like 99.79% probability that they mean that it's increasing to the right.
Right.
Okay. All right. So then this is the first axis and the second axis, and then just like you are to interpret this line as extending infinitely far to the right and infinitely far to the left. This is a plane, and you are to interpret it as extensive all the way out. Okay. So all these points are on the plane. So we could select, for example, this point right here. And the way that that point is named is that you project that point onto the first axis and make a measurement. And let's suppose that on the first axis, that reads as P. And then you project it onto the second axis. And then on that second axis, it reads Q. Okay, notice that when you do that, this shape is a rectangle, which is why this is called a rectangular coordinate system. So if on the horizontal it measures P and on the vertical it measures Q, then what's the name of that point? PQ. P is written first because it's the first axis. Q is written second because it's the second axis. Okay, now again, because I did not write a scale, you can't tell me the exact values of P and Q, right? Because you don't know if I'm measuring this in centimeters or light years. You have no idea. But you should be able to tell me the sign of P. What's the sign of P? It's negative. And how do you know it's negative? Correct, because the convention is that crossing right there, that's where both axes have their zero. Okay, so then P being to the left means that it's less than zero. So then so P must be negative. And similarly, what's the sign of Q? Positive. Okay, in the end, because it is in the world direction from zero, right? So from 0 to Q, you go with the world. From 0 to P, you go against. Okay. Any question about this? So this just kind of brings us back into what we were doing last time. Another aspect of what we were doing last time. So any questions about this before I move to another sheet? Is this okay? So we ended last time talking about this equation. So I could say let y equal 2 multiply x minus 1. Okay, so then notably we've had equations before, but most of the time in such equations there was just one variable. Right? There was and it was usually like x or w or whatever, but there's just one of them. Here, we have two variables, y and x. So the standard convention, okay, is that when the variables are x and y, you are to interpret x as the first one and y as the second, which means that on the axes, x is the horizontal axis and y the vertical. Okay, so here's a question. which I can't state precisely, so I'll put it in kind of like in scare quotes, is say the point 5, 4, and then scare quotes part of this. We'll have a better way to say part of in a few minutes. So specifically, what I'm asking you to do is I'm asking you to please plug in xy equal 5, 4, and check. And notably, when I write 5, 4 like that, do I mean the interval, the open interval from 5 to 4, with the endpoints not included? No. What do I mean? I mean the point, right? So you need to pay close attention. So if I write 13, 14 in parentheses, whether or not that means a point or an interval depends on the context. Okay, so plug it in. That means everywhere you see x in that formula, write 5, and everywhere you see y in that equation, you write 4. So 4 equal 2 multiply 5, subtract 1. And now we're going to simplify both sides. The left-hand side simplifies to 4. The right-hand side simplifies to 9. All right, and again, we got here last time, and I, disturbed some folks. And I'll just, ask again, is this thing here that I'm pointing at, is it an equation?
Yes.
It is. It's an equation. And you might even yet still be disturbed. Well, fine. But understand that what an equation is that, when you write just that much that's between my fingers up there, such a thing is called an expression. That's what it is. Okay, and when you write just 4, that also is an expression. That's what that is. That's like the kind of thing that it is. And then you can evaluate an expression. So when you evaluate that 4, its value is 4. And concerning this 2x minus 1, you can evaluate it at say 5, at x is 5, and that means replace the x with a 5 and do all that arithmetic, and you get a 9. So all that an equation, now be careful, I'm saying two words that both start with e and end with yin. An expression is like that. An equation, what an equation is it's two expressions. One of them that you refer to as the left-hand side, another that you refer to as the right-hand side, and then you just write the equal sign in between. That's what an equation is. So when I ask, is this an equation? I'm literally asking, are there two expressions with an equal in between them? So the answer is yes. It is an equation. But the thing that gets mixed up sometimes until you get to university is the separate question, is that equations evaluate to false or true. That's how they take their value. And concerning this equation, what does it evaluate to? False. And there's nothing like immoral or unethical, okay, or concerning about that. It's just an equation, and its value is false. Okay. Fine. So then, but in that case, what is the answer to the question?
No.
Okay, so the answer is no. Whereas, I could ask, is something like, say, 3, 5 part of it? Well, you address you address it in exactly the same way. So we'll plug in xy equal 3, 5, and obtain 5 equal 2 multiply 3 subtract 1. The left-hand side simplifies to 5. The right-hand side simplifies to 5. So now is that an equation? Yes. What is its value?
True.
True. And as a result, what's the answer to the question?
Yes.
The answer is yes. All right. Fine. So now, item 3. Now I want you to make a table. Well, specifically, I'm going to make a table, and then I want you to fill in the missing spots. Okay. So I'm gonna start with -5, and then -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. All right. So to interpret my request, what I mean by this is that we've got this table with 2 columns. I provided the x column. I want you to fill in the y column so that the corresponding point, when you plug it into the equation will evaluate to true. So now notice that concerning the equation, we established that when x is 5 and y is 4, that the equation is false. So here, when x is 5, I surely am not supposed to write 4. That wouldn't work. Right? But when x is 3 and y is 5, the equation is true. So that's telling me, for no other reason than that when x is 3, I can write a 5 right here, right? And then, okay, now I'm doing good. And what I want to do is I want to fill in fact, all of the y's. Okay, so the quickest way to do this, okay, is to take this equation. For example, at say 4. So that means x is 4. So I'll take the equation, y equal 2 multiply x subtract 1, and I'll replace, look at all that ink. I'll replace the x. I must have dropped the pen. I'll replace the x with a 4. So I'm going to substitute x equal to 4, and then when I do that, I have y equal, 2 multiply 4 subtract 1, so that'd be 7. So now, is this an equation? Yes. So now, here's a tricky bit. So if you weren't already disturbed by what I'm talking about, equations and things like this, is this equation right here, is it true or false or what? It's neither one. It's neither one because you have yet to tell me what y is supposed to be. You know, if I replace that y with a 12, then you can evaluate it, and it will be false. So here's something that's sort of so trivial that it's difficult to say. What y do I need to plug into this equation so that the equation will be true? 7, right? And there's no other y that I could, I'm asking, what if I were to erase the y and write something? What is the one and only thing I can write so that the equation would be true? 7. Okay, it's so sort of obvious it's difficult to say. Okay, but as a result of this, what am I supposed to write here? 7. Okay. So I write 7. And then now that you've seen me do it once, you can probably imagine the way the rest of it goes. You just take that equation, and now that I have 5, I plug in x is 5. 2 times 5 is 10, minus 1 is 9. So 9, right there. Now, for reasons that may not be entirely clear if this is the first time you're seeing this, notice that these are counting up by 2, 5, 7, 9. Is that a coincidence? It is not. But it may not be entirely clear why that's surely not a coincidence. The reason in the end is because of this 2 right here. And what I'm saying is that if instead of being a 2 that were a 22, we'd be counting up by 22. And if it were a 3, we'd be counting up by 3s. So it's easy to fill up the rest of the table by just doing that, right? So then 9, 7, 5, 3, 1, -1, -3, And you might be worried, like, well, I'm not real sure if that's okay. So let's just check this -2 real quick. What if you plug in x is -2? What do you get? You get -5? Is that expected? Yeah. Any question about this? All right. So now, concerning this table, now I'm going to make a plot. And a plot in this context means I'm going to draw a picture. Specifically, what I'm going to do is that I want to plot all points in the table, and I want you to connect the dots. Okay, now, if you look at it carefully there, then I put those those tick marks right there, like that one and the next one and the next one. I'm going to construe those as being the integer points, and then the ones in the middle, those will be half integers, like 3.5 and what have you. So I want to plot all these points in the table, but you've got to understand that means all the ones that would fit, So what I mean is that if this is the origin, 0, 0, then the biggest x we can accommodate is 5.5. And the smallest one that we can accommodate is -5.5. We can't go beyond that. And similarly, the smallest y we can accommodate is -5.5 to 5.5. So in fact, we're not going to be able to plot all of them. So what's one of them that we can plot? So for example, can we plot, say, that one? No, it won't work, right? Because it'll be too low. It'd be down here. But how about that one? Can we plot that one? Yeah, we can plot that one. So let's plot -2, -5. So how do we do that? Okay, left 2 because x is the horizontal direction and left is the negative direction. Okay, so that means from the origin horizontally left 2 positions, and then this means down 5. Fine. 1, 2, 1, 2, 3, 4, 5. So that point right there, that's the point -2, -5. Good. And then how about -1, -3? Will that fit? It will. And it turns out it's right there. -1, -3. Right there. And then 0, -1. Okay, that'd be right here. Okay, now that we've plotted 3 of those points, I'd like for you to observe that, hey, look, they're all like kind of lining up, Is that a coincidence? No. For reasons that aren't entirely clear, it's not a coincidence. But just like every time you move down, this one increases by 2. For the same kind of reason, to get to the next point, you move over 1 and then up 2. Because every time x increases by 1, y increases by 2. So 1 to the right, 2 up. So the rest of them will look like this. And then we can't fit anymore. Blah, blah, blah. And what is this? 3, 5. Okay, no more fit. So it says draw the points and then connect the dots. Okay, so now I'll connect the dots. Okay. So any question about this? All right. So now, what I want you to observe is that we've got. At first, I asked this question, and remember that there was no picture when that was up, right? None of that was there when I asked these questions up here, and now there's a picture. But what I want to show you is that let's ask this question again. Now we already know the answers. We already know that we did some calculation. We determined that an equation is false, and therefore we answered no to the question. So we know that, but ignore that. But remember the point 5,4. So where is 5,4 on this drawing? Right, so over 5 and up 4, right? So that'd be right here. All right. So now, concerning this plot, what we're saying is that this equation, in some sense, is represented by those green dots and the red. So the green and red. That's what it represents the equation. Now, concerning that blue point right there, is that among the green and red points? It is not. It isn't. Okay. How about the point 3,5? So where is it? So here's 3,5 right there. So it was just green, but now it's blue and green, and I colored it again. So is it the case that this point right there is part of the red and green points? It is. It is. Okay, so if I was to select, say, this point right here, now that point would be -3, and then 3.5. That's that point. And now I'm going to ask a different question. What if you were to plug the point xy equal to -3, 3.5? What if you were to plug that into the equation? Would the resulting equation be false or true? It would be false. And that point right there, I don't even know what point I'm pointing to, but that point right there, if you were to plug that point into the equation, would it be false or true? It'd be true. So what I am wanting you to see is that the statement, you select a point, plug it into the equation, evaluate, and determine false or true, is exactly the same question as take this picture, point at any point you care to name, and then the answer to the question, when you plug that point into the equation, is exactly the same as are you pointing to one of these red or green points? These red and green points are exactly and only those points that when you plug into that equation, the result is true. Every other point, including that one right there, if you plug in that one, you plug that into the equation, it'll be an equation, but it will be false. Its value will be false. Okay? Good. So now we need some better terminology. It's not so clumsy to say. First, so if we have an equation in one variable, so given an equation in one variable, and I could say, for example, just so we have something to look at, how about 5 times w squared minus 9 is equal to 0. So there's an example of such an equation. So I could say, what if you plugged in w as 10? Well, then it would read, 10 squared is 100 times 5 is 500 minus 9 is, I don't know, it's 491. So if you plugged in w as 10, the equation would read 491 equals 0. And of course that's false. Okay, but there are in fact some w's you can plug into this equation and the result will be true. So the set of all w such that the equation evaluates to true is called the solution. Solution to the equation in one variable. So again, continuing this example, I'm going to solve it. So we had a question that wasn't exactly this, but it was in fact related to this, that you already turned in. 5w squared minus 9 like this, equal to 0. And the question was, in fact, there wasn't an equation in it. Rather, it was a factoring question. And so, you know, that's an expression. That's an expression. So just ignoring the right-hand side expression and just looking at the left-hand side, a question was asked. I gave you something like this, and I said, you know, factor this by first representing the terms as squares. Okay, and I'm going to do that now, and I'm going to go on to use that to solve the equation. So how can 9 be written as a square? 3 squared, right? So making a little bit of progress, I could say that that this is, you know, minus 3 squared like that. Just a little bit of progress. And now what I want to do is I want to figure out what is it that I need to write in those parentheses there, so that, you know, so that these are the same. Because here's the deal: is that that square right there, as written right there, only applies to the w, because the w is being squared, but the 5 is not, because of the order of operations. So my question is, what do I need to write in there? So I need to put a w in there. What else? A square root of 5. So square root of 5, w, and then square that. All right, now, okay, some people are disturbed by this. I know, because I heard from you. So just as an aside on this, I could say, well, doesn't squaring, doesn't that mean make 2 copies and then multiply them all together? That's what that means. So square root of 5 w squared like that. It means take that thing, duplicate it, and multiply them together. Right? And then multiplication is associative, which means I can drop the parentheses. And multiplication is commutative, which means I can put them in the order I want. And then now we have w repeated twice, and we've got another way to say that. And we have square root of 5 repeated twice, and we have another way to say that. It's like this. And so what is the square root of 5 squared? It's 5. That's why to get from here to here, it's that, right? Okay, so then now the neat thing about this is that now this is referred to as the difference of squares, and you know how the difference of squares factors. How does it factor? I'm fishing for a phrase that starts with P and ends with product of conjugates. Yeah? I refer to that as the joke, okay? And it's supposed to be a little bit aggravating. Okay, it's supposed to be funny, but it's also a little bit aggravating because I'm trying to get you to, you know, beat me. Because if you beat me to the thing, then I won't say it. Okay? So you're all on notice now. The joke will continue. Okay, so then now this factors into the product of conjugates. Fine. So then the product of conjugates says that if you have a squared minus b squared, then you have two binomials, a plus b and a minus b, and those are conjugate to each other. So it factors like this. Square root of 5 w, like that, and then plus 3, and then multiplied by square root of 5 w minus 3 equal to 0. Okay, so now we've got these two things are equal to 0. And you could take some time and like plug in some w's and say like, well, what if I plug in w is 8, and then you could plug it in to that factor into that factor, and you can mess around with it. Suppose that that we find a w, and this equation is true, meaning that the left-hand side somehow does become 0. And suppose that I'm covering this one up, but suppose that when we plug in the particular w I'm talking about, that this one is equal to 8. But nevertheless, the equation is true. Then what does that mean about the one I'm covering up? It has to be 0. Because if that's 8, and that product is 0, then it has to be the case that the one that I'm covering up is 0. Because if this weren't 0, if it were 7, then it would be 8 times 7 is 56. It wouldn't be 0, right? Similarly, if I find some w so that the equation is true, and that factor, turns out to be 40, then what must be true about this one I'm covering up? It has to be 0. So here's the deal, is that we have two things being multiplied together, and the result needs to be 0. That means that at least one of them has to be 0, right? If that one is 0, then that one can be anything else. If that one is 0, then the other one can be anything else. And if they're both 0, that would be okay too. But that's not possible in this case. So what I'm telling you is that this equation, to solve it, it splits into pieces, two pieces. So the equation splits like this. It is either the case that the first factor is 0, or it is the case that the other factor, the second factor, is 0. Because that's the only way that this could be satisfied. And understand that or means conceivably these could both be 0. That'd be fine too. So, how do we solve just, say, that one by itself? Yeah. So I'll subtract 3 from both sides. So that I get square root of 5w minus 3. And now what? Very good. So now divide by that multiplier there. So divide by square root 5. The new left-hand side is what? W. The new right-hand side is? Very good. Negative 3 over square root 5. And now, this will probably be the last time I say it, but this equation right here, this one that I'm pointing at, is neither false nor true, because we haven't specified what we want w to be. But do you understand that this equation could only be true if w is negative 3 over 5, negative 3 over the square root of 5?
Yes.
Okay, good. So now I'll stop saying that. And then concerning this one, it's solved in a completely similar way. So add 3. Divide by square root 5. Okay, so then the way that you are to interpret this is that these w's, these are the only w's, such that when you plug in those w's into that equation, the result is true. You're permitted, it's fine, it's completely permissible for you to plug in 10. but it just won't be true. But if you plug in 3 over the square root of 5 into that equation, it will be true. So the conclusion here is that, therefore, the solution is w equal to negative 3 over square root 5, or w equal to 3 over the square root of 5. And then we could draw it like this, if we wanted. Draw the number line there, and then there'd be just 2 points, okay? And I'd fill them in solid there, that one, and then this would be negative 3 over the square root of 5, like that, and this one would be 3 over the square root of 5. And then now visually I could ask, concerning this equation right there, 5w squared minus 9 equals 0, what if I plug in that point? Would the equation be false or true? It'd be false. What if I plug in that point? True. So the question of whether or not I plug in a point and the equation is false or true is now equivalent to asking whether or not I'm pointing to a red point. Okay? So now, I mention that because here's something that is surprising, possibly, given an equation in 2 variables now. So, for example, y equal to multiply x minus 1. So that's an equation in 2 variables. The set of all xy such that the equation evaluates to true is called, now this is one of the places where I wish I could go back in time to when these conventions were being set down, and I would tell those folks there, I would say that okay, you can call this solution, that's fine. If you call it that's fine, call it solution, but it seems surely true that you should call this one solution also, right? But it's not. So when you're dealing with equations that have just one variable, then this set, the set of all inputs which cause it to be true, is called solution. But when you're dealing with an equation of more than 2 variables, the set of all inputs which cause it to be true is called the graph. Of the equation. And I want to point something out to you, a place where you probably misled, is that I'd like to point out what kind of thing is a graph. Is it like a squirrel, or like a like a verb? What is it? No, it's a set. That's what it is. And I want to stress that that this definition of the word graph has no mention whatsoever of a picture. So if in your head graph and picture are synonymous, we now need to dissect them. They're not the same. Graph is a set. Now, it's very useful to look at a picture of a graph. Now, what's the name for a picture of a graph? A plot. Okay? So that's what we did on the previous page. So when I ask, is 5,4 part of that? The proper way to say that is 5,4 in the graph? That's the correct statement. Okay, now, if you were to plot all the points where this equation is true, then it looks like it did on the previous page. It looks like this. But what I want you to observe is that's completely analogous to this. Right? Will this input cause the equation to be true? Yes, because it's red. No, because it's graphite. Will this input cause that equation to be true? Yeah, because I'm pointing to a red point. What about that input? No, because I'm not pointing to a red point. Okay, good. How much time do we have? 30 seconds? No, we've got lots of seconds. So the next thing is that we have something called intercepts. So there's something called an x-intercept. Algebraically, this is when y is equal to 0 for an equation in two variables, and a y-intercept. Me too. This is when x is equal to 0. So now, when you draw an axis, now without a scale, you can't. So I'm pointing to a point on the plane, but it happens to be there. Without a scale, you can't tell me exactly what the x value is, assuming that the horizontal one is x. But in fact, you can tell me exactly what y value, what the y value is of that coordinate. What's the y value? It's 0. Because if you project the place I'm pointing over to the vertical, then it's on the origin. So this line that we printed on the previous that we drew previously, does it have an x-intercept?
Yes.
Yeah. And the reason why it's called an x-intercept is because this is the x-axis, and the question is where is the red touching the x-axis? Well, right there, right? So that's an x-intercept. Does it have a y-intercept? Yes. And it's called a y-intercept because that's where the red touches the y-axis. And then, you can get entertaining and, make something like this. And then ask, how about that thing that I drew? Does it have any intercepts? Yeah. Does it have x1s? Yes. It's got one x-intercept, right? Does it have any y-intercepts? Yeah, it's got a bunch of them. And then you can make just some drawing that doesn't have any intercepts. That'd be fine too. All right, have a nice weekend.